Hello and welcome. In this video, we're going to begin Unit 3, which is going to lay the foundation for the rest of this geometry course. In this lesson, we're going to focus specifically on points, lines, and planes and what they are and how we can use and identify and write them. So our goals in this lesson are that we can identify and label figures in a drawing using the appropriate notation, that we can look at a drawing and recognize that points are collinear, coplanar, non-collinear, or non-coplanar, and that we can identify and define figures formed by intersections of lines and planes. So let's go ahead and jump in. So as usual, we're going to start with vocabulary, and there's really a lot of vocabulary in this section, but the good news is you have been using many of these things for a really long time, and hopefully not much of this is new. So the first word is a point. You've been plotting points since middle school math. This is an example of a point here. A point is defined to have no dimension. We represent it as a dot. A line, our second word, is just what we get when we connect 2 points. A line has one dimension. It's represented with 2 arrowheads, so it's important to note that a line goes forever in both directions. So it extends without end. Through any 2 points, there is exactly one line. So you see points A and B are on line L. Or we could write AB with the line symbol over it. A, B, and we would draw a little line over it. So we could call this line line L. We could use the word line AB, or we could use AB with the line notation above it. And all of those things could also be written as BA instead of AB. The next vocabulary word is a plane. A plane is basically like a piece of paper. It has 2 dimensions. It looks sort of like a floor or a wall, but it extends forever without end. So even though we're only seeing a portion of this plane here, we're pretending that it goes on forever in all directions. Any 3 points can define a plane. And here you can see this is labeled as plane M, which does not have plane M. There's not a point there, so I could call it plane M if it's named this way, or I could use 3 points to define it. This is plane ABC or BAC, any combination of those 3 letters. All right, next we have collinear points. Collinear points are just points that are on the same line, and you can actually see the word line right there in the middle of the word collinear. So in this graphic over here to the right-hand side, we have 3 collinear points, A, B, and C, because they are all on this line. A and B are collinear, B and C are collinear. All 3 of them are collinear on the same line. Similarly, coplanar means that we have points that are in the same plane. So you can see over here to the right again, all 4 of these points, A, B, C, D, are in this same plane. So we would call those points coplanar. Now, we mentioned that a line goes on forever in both directions. If we're just looking at a piece of the line, then what we're actually looking at is the segment. The notation for segment is this little line that doesn't have arrows. It's a segment above the letters that we're using. So a segment is just a piece of a line. The key thing about a segment is that it has endpoints. So it starts and it ends. It doesn't matter which way you say this is segment AB or segment BA. All that matters is that it does have 2 endpoints. It stops. If there's only one endpoint, then we call that a ray. It has one endpoint and it extends forever in one direction. So you'll see the symbol for ray has an arrow pointing one direction, and that direction is the direction that the ray is traveling. So AB and BA could be the same segment, but they are different rays because the direction that they're pointing is different. 2 rays are opposite rays if they are exactly pointing the opposite direction. So they share an endpoint, but they're going opposite ways. So CA and CB are opposite rays. They share the same endpoint, but they're pointing in opposite directions. And lastly, intersection is where 2 things cross. 2 lines will intersect at a coordinate. 2 planes are going to intersect at a line. And we'll go into intersections a little bit more in a different section. So now that we've laid the foundation with our vocabulary, let's go ahead and make sure we can apply this vocabulary in some different types of problems. All right, so here we have some examples where we're going to be looking at this diagram here on the left-hand side. We have a plane, we have a line going through the plane, we have a line lying within the plane, there's a bunch of coordinates. So our goal is to apply these vocabulary terms by looking at this specific plane. So the first thing we're going to do is we're going to give two other names for the line PQ. So first, let's find that line. Here is that line PQ right here. So a line can be defined with any 2 points. We could also define this line, or we could call this line QP. Since it goes forever in both directions, the order of the letters doesn't matter. And then, what is this letter here? There's a little lowercase n, and it's not related to a coordinate, so we could also call this line N. Number 2 says name 3 points that are collinear. So let's look at a different line. Let's look at this line here. 3 points that are on this line look like S, P, and T. Points S, T, and P are all collinear because they are on the same line. Give 2 other names for plane R. So a plane can be defined with any 3 points. So we could call the plane VST. We could call the plane SPV. Any 3 points that are on that plane, preferably 3 points that are not on the same line, because that would be more defining the line. And then lastly, name 4 points that are coplanar, so that are in the same plane. So points V, T, S, and P are coplanar because they are all in that flat plane. R, not plane, are coplanar. All right, let's look at another example. All right, here we have another diagram, and we're being asked 3 questions. Give another name for segment GH, name all of the rays that have an endpoint of J, and then identify which of those rays in number 7, this is backwards, sorry, which of those rays in number 7 are opposite rays. So go ahead and pause the video and see which of these you can do on your own, and then unpause the video and see how you did. Okay, hopefully you had time to work on this. Another name for GH, segment GH, would be segment HG. And that's the only way that you can write it, because a segment has a specific length and it's only the values or only the distance between those 2 points. I'm going to do number 7 first. Name all the rays with endpoint J. So J could go towards G. It could also go towards H. Those are opposite rays. So J, G, ray JG, and ray JH are opposite rays because they point in opposite directions. And then similarly, JF and JE. And those 2 are opposite rays because they point in opposite directions and they share an endpoint. Let's look at another example. All right, take a look at these next few problems. Pause the video and see if there's any of them that you can do on your own, and leave the ones that you can't do to walk through with me. If there's symbols or notations that you're not sure on, just skip those ones for now, but give yourself the chance to see what you can do on your own, and then unpause the video and we'll work through them together. All right, hopefully you've had time to work through these on your own. Number 8 says name the intersection of the line PQ and the line K. Well, here's PQ and here's K, and it looks like they are intersecting at point M. Number 9 says name the intersection of line K, so the line we were just looking at, and plane A. Line K and plane A are also intersecting at point M. Number 10 says name the intersection of plane A and plane B. The 2 planes are intersecting at a line. They are intersecting at line K. All right, number 11, just as a reminder, this symbol means perpendicular, which means they're intersecting at a 90-degree angle. So it's asking, are AC and BD perpendicular? And the answer is yes. This symbol here is indicating that they are intersecting at a 90-degree angle. And then number 12 says, are EA and EB, so EA is starting here, EA and EB, are they opposite rays? And they do have the same endpoint. They do start at E, but they're not going in opposite directions. They're going in different directions, but not in opposite directions. So no, EA and EB are not opposite rays. All right, for our last 4 examples, we are going to sketch some different figures. And don't get too hard on yourself. Some of these things are really hard to draw, but the goal is just that we're thinking through these vocabulary words and what it would look like if we sketched their intersections. So number 13 says a plane and a line that is in the plane. So a plane is just going to look like some sort of quadrilateral. And then a line that's inside that plane is just going to be a line that lays flat within that plane. And I'm going to go ahead and label these. So I'm going to call this plane A, and I'm going to call this line L. Number 14, a plane and a line that does not intersect the plane. So I could have plane A, and then down here below plane A, I could have line L. And they aren't intersecting because they're parallel, or they're not running into each other in any way. Number 15 says a plane and a line that intersects the plane at one point. So here I have plane A, and then I could draw a line that's cutting through it and intersects maybe at point M. And lastly, sketch two planes that intersect in a line. So here I'm going to draw plane A, and I'm going to try to draw another plane. And this could be, let's use a different color. This could be the line where they are intersecting. So this is plane B, and we could call that line L. Okay, let's wrap up this video. All right, in this section, we were focusing on points, lines, and planes. We defined those. We defined the notation that goes with them. We sketched them. We identified different components from a graph. So go ahead and write down any questions you have, and I look forward to working with you on this. Thanks for listening.